Hi and welcome to today's video. So this is going to be video number 10 in trigonometry. So today we're going to be looking at functions or equations that actually have inverse trigonometric functions involved. So let's introduce this. So we know that sine inverse of theta is the angle whose sine is theta, and then cos inverse of theta is the angle whose cosine is theta. And then lastly, we also know tan inverse of theta is the angle whose cosine is theta. So now these are going to be the foundation of what we're going to be looking at in this section. All right, so let's look at some numbers here. So this is a question. This is going to be question number 1. So we're being told to show that tan inverse over half plus tan inverse of 1 over 5 is equal to tan inverse of 7 over 9. How do we deal with this question? All right, so let's look at the solution. So what we're going to do is the first step is we're going to look at everything from the left hand side. We're going to try to prove from the left hand side into the right hand side, since this is actually a proof question. So what we're going to do is we're going to let A to represent tan inverse over half, and then we're going to let B to represent tan inverse of 1 over 5. So when we've done this, we can actually now see from here that this means that tan of A is equal to a half, and then the same thing here, we can also see it means that tan B is 1 over 5. So now that we know that and we've actually replaced them that way, we can actually see that now what we'll have is A plus B being equal to tan inverse of 7 over 9. And then we can actually see that now we can actually bring this tan to this side. So when you do that, we'll actually have tan A plus B being equal to 7 over 9. So you may ask yourself, why did I actually put this value on the right hand side? It's because I wanted to know and to see clearly what direction that I actually need to go. Since the value that we need to prove on the other side is actually a tan inverse of 7 over 9, and then we've given this and this the value A and B, what we can see is what we actually have to prove is that tan of A plus B is going to be equal to 7 over 9. So the proof actually comes from tan A plus B right here. So we have to prove that tan A plus B shall be equal to 7 over 9. So now again, we're going to look at this left hand side right here. So remember, tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So we're going to substitute the values. So where there is tan A, we put a half, and where there is tan B, we put 1 over 5. Then right here, we can see that we have their products, 1 over 2 times 1 over 5. So as you can see at the top, when we add the 2, we'll have 5 plus 2 over 10. And then at the bottom, when you open these brackets, actually multiply this and this will get 1 over 10. And then right at the top, we'll have 7 over 10. Then at the bottom, when you find the LCM, we'll actually see we'll have 10 minus 1 over 10, which is 9 over 10. So we'll have tan A plus B equal to 7 over 10 divided by 9 over 10, which can be represented as this. Now, as you can see, we can actually change that division sign into a multiplication sign, and we'll have 7 over 10 times 10 over 9, which shall be equal to 7 over 9. So you can say that tan A plus B is equal to 7 over 9. Now, all we can also see that we can actually now put everything back into the terms of A plus B by taking the tan to the side. So you can see that A plus B shall be equal to tan inverse of 7 over 9. But remember that A represents tan inverse over half and B represents tan inverse of 1 over 5. So therefore, tan inverse over half plus tan inverse of 1 over 5 is equal to tan inverse of 7 over 9, and hence we've proved this. Alright, so question number 2. So being told to find the positive value of theta, which satisfies the equation tan inverse of 3 theta plus tan inverse of theta is equal to pi over 4. Unlike the first example, this is not a proof question. So here basically what we just want is to find the positive value of theta. So the same thing we're going to do as in the former question. We're going to let A to be equal to tan inverse of 3 theta. Then we're going to let B to be equal to tan inverse of theta. So we can already see from here that this means that tan of A is equal to 3 theta. And then right here we can see that it means tan B shall be equal to theta. So this then becomes, so we'll end up having A plus B being equal to pi over 4. And then, as you can see, we can actually introduce tan on both sides. So I'm going to introduce tan on both sides to actually solve this more easily. So I've chosen to introduce tan, and then I'll have, so I've introduced tan on this other side of the cosine and this other side too. So I'll have tan A plus B and tan pi over 4. So as you can see on the left hand side, we have tan, this becomes tan A plus tan B over 1 minus tan A tan B. And then on the right hand side, I'll have, we know that tan pi over 4 is 1 because it's the same as tan of 45 degrees, which is actually equal to 1. So next we can now put in back the value. So where there is tan A, we put 3 theta, and where there is tan B, we put theta. So this is what we end up having. So when I add this, I can see 3 theta plus theta is 4 theta, and then 3 theta times theta is 3 theta squared. So this is what I end up having. So I can cross multiply and I'll have 4 theta being equal to 1 minus 3 theta squared. So now I'll organize this to have a quadratic equation, which shall be 3 theta squared plus 4 theta minus 1 being equal to 0. So now whatever way you solve this, either using the quadratic formula or either your calculator, you should come up with theta being either 0.2153 or theta being equal to negative 1.5486. But we've been asked to find the positive value of theta, so therefore we shall only consider the positive. So therefore the positive value of theta is 0.2153, and that is the answer they wanted. Alright, so question number 3, we're being told to show that there is a positive value of x for which tan inverse, or in bracket 2x plus 1 plus tan inverse in bracket 2x minus 1 is equal to tan inverse of 2. So we're going to follow the same steps. Now this is also another case where we actually just simply have to find the value of x. So we're not proving here, we're just solving for x. So we're going to let a to be equal to tan inverse of 2x plus 1, and we can let b be equal to tan inverse of 2x minus 1. So now what this means is that tan of a, from here tan of a shall be equal to 2x plus 1, and then from here we can see a tan of b shall be equal to 2x minus 1. So this then becomes a plus b being equal to tan inverse of 2. So now we can actually bring this tan to this side. So a tan inverse is brought to this side and we have tan a plus b being equal to 2. Alright, so tan a plus b shall be equal to tan a plus tan b over 1 minus tan a tan b being equal to 2. Now we're going to substitute in the values. So where there is tan of a, we shall put in 2x plus 1, and where there is tan b, we shall put in 2x minus 1, as you can see right there. So at the top, when I add all those terms, I'll end up having 4x, because this one and this one cancel. Then right at the bottom, when I open these brackets and multiply, I'll end up having 4x squared minus 1, and this shall be the answer right there. Now next, I'll actually cross multiply. So when I cross multiply, I'll have 4x being equal to, so this 2 multiplies this, and I'll have 2 minus 2 into bracket 4x squared minus 1. So the next step is I can open these brackets and I'll have negative 8 squared plus 2, as you can see right here. So there'll be a change of sign right there. Alright, so next I can see that this 2 and this 2 can add them together and I'll have 4. So I end up having 4x being equal to 4 minus x, 8x squared. Then if I organize this to have a quadratic equation, I'll have 8x squared plus 4x minus 4 being equal to 0. Now I can see that I can divide both sides by 4 to reduce this, and I'll have 2x squared plus x minus 1 being equal to 0. So solving this quadratic equation either using a calculator or either using the quadratic formula, I'll end up having x as being either a half or x being equal to negative 1. So therefore, now we're looking for the positive. So therefore, there is a positive value of x and it is a half, and that's what they wanted. Alright, so question number 4, we're being told to show that cos inverse of 63 over 65 plus 2 tan inverse of 1 over 5 is equal to sine inverse of 3 over 5. So this is now a proof question. So this is going to be different. So that means we're going to be proving from one side into the other. So now let's see what we shall do. So we're going to let a to be equal to cos inverse of 63 over 65, and we're going to let b be equal to tan inverse of 1 over 5. So we can now see that this means that cos of a shall be equal to 63 over 5, and it also means that tan of b shall be equal to 1 over 5. So when I put everything back right here, this equation now becomes 1a plus 2b being equal to sine inverse of 3 over 5. Now I can bring this sine to this side, and then I'll have sine a plus b, I mean a plus 2b equal to 3 over 5. So that means that what we end up having to prove is we have to prove that sine a plus 2b is equal to 3 over 5. So now we can now prove from the left hand side. So as we can see from the left hand side, this sine a plus 2b can be expanded using the knowledge of compound angles, and it will become sine a cos 2b plus sine 2b cos a. And then I can see that cos 2b is the same, can be expanded as, because this is actually a double angle, this shall become cos squared b minus sine squared b, and then sine 2b shall become sine 2 sine b cos b, as you can see right there. So now that we have that, so this is basically the equation that we have. Now we actually have some missing terms that we actually have to find. So as you can see already, we know what cos of A is and we know what tan of B is, but we don't know what sine of A is, and then we also don't know what sine of B and cos of B are. So those we shall have to solve and find. But good enough, because we know some of the terms, we can actually find them using right angled triangles. So where cos of A is equal to 63 over 5, we can draw a right angle triangle where we're going to let the angle to be equal to A, and then we can see, we know that from the knowledge of trigonometry, using that short form SOHCAHTOA, that cos is the same as adjacent over hypotenuse. So that means that the adjacent is 63 and the hypotenuse is 65. So from Pythagoras theorem, a squared plus b squared is equal to c squared, we will have 63 squared plus b squared being equal to 65 squared. So b squared shall be equal to 65 squared minus 63 squared, of which 65 squared is 4,225 and 63 squared is 3,969. So when you subtract that, we'll have b squared being equal to 256, and then the square root of 256 shall be equal to 16. So now we know what this opposite side of this angle A is. So now that we know that, we can now therefore see that sine of A is equal to, of course sine is the same as opposite, the opposite over the hypotenuse. So the sine of A shall be equal to 16 over 65. How about the rest? So we need to know what sine of B and cos of B are. So good enough, we know what tan of B is. So we're going to draw another right angle triangle where we're going to have the angle as B, and then we know that tan simply means opposite over adjacent. So that means that the opposite is 1 and the adjacent is 5. So from Pythagoras theorem, we'll have this. So we have 5 squared plus 1 squared being equal to 6 squared. So we need to find that hypotenuse. So we'll end up having 25 plus 1. So c squared is 25 plus 1, which c squared shall be equal to 26. And then the square root of that is the answer. So we'll have c being equal to root of 26. So now that we know that, we can therefore see that sine of B is 1 over root of 26 and cos of B is 5 over root of 26. So now that we know all those, we can actually now substitute everything back into our main equation, and this is what we end up having. So now we can see that when we square these values here, we have 25 over 26. When we square this, we'll have 1 over 26. And then as you can see, as when we multiply all these values, we are left with 630 over 1690, of which now when we subtract these values in the brackets, this minus this, they have the same denominator. We'll have 24 over 26. So next we can actually now multiply this to this, and we'll have 384 over 1690. Now at this step, we can actually set the denominators are the same, so we can actually add the numerators directly. So in add them, we'll have 1014 over 1690. So now the next step shall be to reduce. So when we reduce, let's first divide everything by 13, the top and the bottom by 13. So we'll have 78 over 130, but this can still be reduced further. Let's divide everything by 2, and we'll have 39 over 65. So at this stage, I can again divide both by 13, and I'll end up having 3 over 5. So now we have sine A plus 2B being equal to 3 over 5. So now I can take this sine back the other side, and I have A plus 2B being equal to sine inverse of 3 over 5, of which we know what A is. We know that A is cos inverse of 63 over 65, and we know that B is tan inverse of 1 over 5. So we substitute all those back, and then we can now see that cos inverse of 63 over 65 plus 2 tan inverse of 1 over 5 is equal to sine inverse of 3 over 5, and hence we have proved the number. Alright, so question number 5, we're being told to prove that sine. So now this is sine, and then there is a bracket. Inside the bracket, we have 2 sine inverse of x plus cos inverse of x. Alright, so this is also an easy one. So the first step shall be to let A be equal to sine inverse of x, and we're going to let B to represent cos inverse of x. So basically now we can see that this will mean that sine of A is equal to x, and here we can see that it will mean that cos of B is equal to x. So now we can already see that when we put everything back, remember that we have this sine outside, so we're going to substitute this back. So where there is sine inverse of x, we shall put A. So we'll end up having sine into 2a plus b is equal to root of 1 minus x squared. So now this is what we have to prove. So we have proved that sine of 2a plus b shall give us root of 1 minus x squared. So now when we look at the left hand side, we can actually expand it. So when we expand it, we have sine 2a cos b plus sine b cos 2a. But we know that sine of 2a is the same as 2 sine a cos a, because this is a double angle, and then this double angle cos 2a shall be cos squared a minus sine squared a. So now this is what we end up having. So multiply this in and we have this. So we have 2 sine a cos b plus sine b cos squared a minus sine squared a. So now we are fortunate in this case, but there are some values and terms that we actually don't know what they represent. Now we know that sine a is x and we know that cos b is x, but we don't know what cos a represents, and we also don't know what sine of a represents. We know what sine of a represents, but we don't know what cos of a actually represents. So we need to find cos of a, and we also need to find sine of b right here. So those we can solve using right angle triangle. So this is what we have. So now where sine of a is x, now remember that we can represent that as x over 1. Now in a right angle triangle, that will mean that where we have an angle a, it means, because sine of a means opposite over hypotenuse, it will mean that the opposite is x and the hypotenuse is 1. So from Pythagoras theorem, we have a squared plus b squared is equal to c squared. We'll have a squared plus x squared is equal to 1 squared. And then a squared shall be equal to 1 squared minus x squared, and then a squared is 1 minus x squared, because 1 squared is 1. And then if we find the root of that, we can say that a is root of 1 minus x squared. So now we know what the adjacent value is. So if we know that, it means that therefore cos of a, which is basically, we know cos is adjacent over hypotenuse, is going to be root of 1 minus x squared divided by 1, which can basically be represented as root of 1 minus x squared. So now where cos of b is equal to x, remember we can also represent that as x over 1. We can put that on a right angle triangle. Now cos of b simply means that we have adjacent, so the adjacent shall be equal to x and the hypotenuse is 1 from the knowledge of SOHCAHTOA. So we can see that the adjacent is x and the hypotenuse is 1. So from Pythagoras theorem, we'll have a squared plus b squared is equal to c squared, of which x squared plus b squared shall be equal to 1 squared. And then if we make b squared the subject, b squared shall be equal to 1 squared minus x squared, of which 1 squared is 1. So we have b squared being equal to 1 minus x squared. Then b shall be equal to root of 1 minus x squared. So now that we know that, it means, now we know the opposite value here. So it means that therefore sine of b is root of 1 minus x squared. Alright, so therefore when we substitute everything back in, we'll have this right here. Now next we can multiply the values, and we know that 2 times x shall be equal to 2x squared, then times this root of 1 minus x squared plus root of 1 minus x squared into the bracket. So you know the square of this, because there is a root here, this root shall cancel with that, and we'll be left with 1 minus x squared, then minus this x squared. And then the next step is, you can see that minus x squared is going to be equal to negative 2x squared, as you can see right there. So the next step shall be to multiply this inside the bracket, and I'll have 2x squared into root of 1 minus x squared plus root of 1 minus x squared minus 2x squared times root of 1 minus x squared. Now the next step you can see is that this and this are actually exactly identical, so they will cancel, and I will be left with root of 1 minus x squared. But you remember that you remember what a and b represent. So you remember that this shall be the same as this. Now remember that a represents sine inverse of x and b is cos inverse of x. So therefore sine of 2 into sine inverse of x plus cos inverse of x shall be equal to root of 1 minus x squared, and hence we've proved it. Alright, so question number 6, we're being told to prove that tan inverse over half plus tan inverse of 1 over 5 plus tan inverse of 1 over 8 is pi over 4. So in this case we actually have 3 different parts adding themselves, but this is actually also an easy one. So the first step is we're going to let a to be equal to tan inverse over half, which shall mean that tan of a is a half. Then we're going to let b to be tan inverse of 1 over 5, which shall mean that tan of b is 1 over 5. And then we're going to let c to be equal to tan inverse of 1 over 8, which shall mean that tan of c is 1 over 8. So now this then becomes a plus b plus c being equal to pi over 4. So remember we are proving, but we first replaced these values here with a, b and c, as you can see right there. Alright, so the next step shall be, I'm going to introduce tan to both sides as a way of solving this number. So we have tan a plus b plus c being equal to tan pi over 4. So now what I'm going to basically do now is I have to prove that tan of a plus b plus c shall give me tan pi over 4. So now let's focus on the left hand side, and then we know tan pi over 4 is actually equal to 1 because the same as tan of 45, which is 1. So I have to just basically prove that this shall actually give me 1, which is tan pi over 4. So let's look at this left hand side. So now we can see that because there are 3 characters, I'm going to first group these 2 characters here. So I'm going to group the a and b. So I have a plus b and then plus c. So when I group these 2 characters and then I expand, when I expand into compound angles, I'll end up having tan into bracket a plus b plus tan c over 1 minus bracket tan a plus b times tan of c. Alright, so now next I can now expand these here. So now I can expand tan a plus b in both the numerator and the denominator, and then I'll have tan a plus b plus c being equal to tan a plus tan b over 1 minus tan a tan b plus c tan c over 1 minus bracket tan a plus tan b over 1 minus tan a tan b times tan c, close that bracket. So now that we have this, I can now substitute in all the values. So where there is tan of a, I'll put a half. Where there is tan of b, I'll put 1 over 5, and where there is tan of c, I put 1 over 8. So now basically what we're left with is to solve. So now from here I can say that what I'll get at the top here is going to be 7 over 10. Then right here, this times this shall give me 1 over 10, and then also here this shall give me sin of 1 over 10, and then this shall give me 1 over 10, as you can see right there. So now basically the next step is I can actually just solve this. So 1 minus 1 over 10 shall give me 9 over 10, and then the same thing basically here, I'll have 9 over 10 also. Alright, so now the next step is I can see that 7 over 10 divided by 9 over 10 shall give me 7 over 9, then plus this 1 over 8, and then right here 7 over 10 divided by 9 over 10 shall give me 7 over 9, then times this 1 over 8. So now at the top I can find the LCM and then solve that. So I'll end up having 65 over 72. Then right here 7 over 9 times 1 over 8 shall give me 7 over 72. Alright, so 1 minus 7 over 72 shall be 65 over 72, as you can see right here. So now these terms at the top and the bottom, the numerator and denominator, are exactly identical. So that means when they divide each other, I'll end up having 1, of which we know that tan pi over 4 is actually 1. So now we have tan a plus b plus c is equal to 1, which is basically the same as this. Now we can take this tan back to this side, and I'll have a plus b plus c being equal to tan inverse of 1, of which we know tan inverse of 1 is pi over 4 or 45 degrees. So therefore this is what we have. Now remember, the reason we're able to do this is because pi basically represents 180. 180 divided by 4 is 45. So now basically when we substitute in the values of a, b and c, we have tan inverse over half plus tan inverse of 1 over 5 plus tan inverse of 1 over 8 is equal to pi over 4, and hence we've proved the number. Alright, so question number 7, we're being told to show that sec inverse of 5 over 3 minus sec inverse of 5 over 4 is equal to sec inverse of 25 over 24. So when you look at this number from first step, it actually looks complex, but it's actually a very, very easy number. So how do we solve this? So as usual, we're going to let a to represent one of the values on the left hand side. So we're actually proving this. So let's first convert them into a and b. So this will mean that sec of a is 5 over 3. Then we're also going to let b be equal to sec inverse of 5 over 4, of which it will mean that sec of b is 5 over 4. So now this then becomes a minus b is equal to sec inverse of 25 over 24. So now let's bring this sec to this side. So we'll have sec a minus b is equal to 25 over 4. So now basically what this means is all we have to do is we have to prove that sec of a minus b shall give us 25 over 24. So let's focus on the left hand side. So we know that sec of a minus b shall be is the same as 1 over cos a minus b. Alright, so now the next thing is when we expand cos bracket a minus b with the knowledge of compound angles, we know that it shall give us cos a cos b plus sin a sin b. But now we can easily find what from here we can easily find what cos of a is, and we can easily find what cos of b is. But we'll need to find a way of finding sine of A and sine of B. So let's look at what I mean. So where we know that sec A is 5 over 3, so that basically means that 1 over cos A is 5 over 3, and then that means cos of A shall be equal to 3 over 5. So now we're going to use this knowledge to find what sine of A is. So we're going to put this in a right angle triangle, and then the angle is A, the adjacent is 3, and the hypotenuse is 5. So now we need to find the opposite, but we shall use Pythagoras theorem. So now A squared plus B squared is C squared, and then it means that 3 squared plus B squared is going to be equal to 5 squared. So when we make B squared the subject, we'll have B squared being equal to 5 squared minus 3 squared, of which B squared shall be the same as 25 minus 29, which is 16. Then we find the square root of 16, which shall be equal to 4. So therefore the opposite is 4. So what this means is that sine of A, of which sine is opposite over hypotenuse, shall be equal to 4 over 5. Now where sec of B is 5 over 4, we know that means that 1 over cos B is 5 over 4. So it means that cos of B is 4 over 5. So now put this in a right angle triangle. We shall use cos of B to find what sine of B is. So the angle is B. It means that the adjacent is 4 and the hypotenuse is 5. So from Pythagoras theorem, A squared plus B squared is C squared. We'll have 4 squared plus B squared being equal to 5 squared. So B squared shall be equal to 5 squared minus 4 squared, of which this is 25 minus 16, which the answer shall be 9. So the square root of 9 is 3. So B shall be equal to 3. So that's what we have. So that means that sine of B, which is opposite over hypotenuse, shall be equal to 3 over 5. So therefore we now have sec of A minus B shall be equal to this. So we'll have 1 over 3 over 5 times 4 over 5 plus 4 over 5 times 3 over 5. So when we multiply those, we have this. So we have 1 over 12 over 25 plus 12 over 25. So we add those two fractions and we'll have 24 over 25. So sec A minus B is 1 over 24 divided by 25, of which that is basically the same as 25 over 24. And then we can now take the sec back to the other side. So we'll have A minus B being equal to sec inverse of 25 over 24. But remember that A represents sec inverse of 5 over 3, and then that B represents sec inverse of 5 over 4. So therefore we have sec inverse of 5 over 3 minus sec inverse of 5 over 4 is equal to sec inverse of 25 over 24, and hence we've proved the number. Alright, so now that we've done those, I have an exercise for you. These are going to be 10 different numbers. So I have the answers right next to each question that you can compare with what you find to make sure that you're actually on the right track. So I encourage you to try these numbers out, and I believe that after you've done these numbers, you actually have a better understanding of these inverse trigonometric functions. So this is question 1 to question number 6, and then this continues. So you have question number 7, question number 9 up to question number 10. So from question number 7 to question number 10, we're asked to prove the following. So I encourage you to actually try these out. Thank you for watching. Thank you for watching this video. I hope this video really helped you. If it did, feel free to leave a like on the video, and then feel free to share with all your friends so that they can also be inspired, and it could also be a blessing to them. If you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching. See you all in my next video.